Behind the moon, there's an orange tail stretching 400,000 kilometers long. Not a comet. It's the moon you see every night. Wait, how does the moon have a tail? It doesn't even have an atmosphere, and that's exactly the problem. With no atmosphere for protection, the surface is completely exposed to space. The solar wind, millions of tons of high-energy particles blasting from the sun every second, slams straight into the lunar surface. Imagine sanding a bar of soap. Shavings flying everywhere, right? That's basically what happens when solar wind hits sodium atoms in lunar soil. The process is called sputtering. High-energy particles strike, and sodium atoms get knocked flying. The moon's gravity is too weak to hold them back. Once sodium atoms leave the surface, they never come back. These escaped sodium atoms gather together, forming the moon's exosphere. Call an atmosphere, but it's so thin it barely exists. But sodium atoms don't just hang around. Solar radiation pressure pushes them away. Like wind scattering dandelion seeds, sodium atoms get swept behind the moon. Farther and farther, until they stretch into a tail hundreds of thousands of kilometers long. In 2000, astronomer Jeffrey Baumgartner at Boston University captured it with a special filter. He only looked at the sodium D line, light at a wavelength of 589 nanometers. At that wavelength, the moon's sodium tail shines bright as a banner. Here's where it gets really interesting. During a full moon, the sun, moon, and Earth line up. The moon's sodium tail points directly at Earth. These sodium atoms plunge into Earth's upper atmosphere and actually glow. NASA data confirms that sodium levels in Earth's upper atmosphere rise around every full moon. The moon looks perfectly still, but it's been bleeding this whole time. Solar wind bombards without pause, and sodium atoms escape without end. Next time you see a full moon, remember, it's wagging its tail right at you.